All right, if you've ever found yourself just staring at a progress bar, slowly, very slowly, creeping across the screen of a legacy Delphi app, then you are in the right place. Today, we're going to tackle one of the biggest headaches in maintaining those mature code bases, performance. Let's dive in and see how we can turn that slow code into some seriously pro code.
So you might think slow code is just, a minor annoyance. But it's so much more than that. It's like this silent tax on your whole operation. It leads to frustrated users, a mountain of support tickets, and a dev team that's constantly putting out fires instead of building cool new stuff. So what's the real cost here? It's lost opportunity, plain and simple.
Okay, every good story needs a villain, right? So let's give our enemy a name, slow code. You know exactly what I'm talking about. It's that one function, that one module in your app that just sucks the life out of the whole system. It's the antagonist in our application story, just lurking in there, waiting to make things grind to a halt. And finding it? Well, that's the first step to taking it down.
And here's the official definition. But listen, the most important thing to get from this is that slow code, it's not a hardware problem. You don't need to throw more servers at it. It's a software problem, which means we can fix it. We're talking about clunky algorithms, using the wrong kind of list for the job, or just doing the same calculation over and over. And you know what the best part is? It means we have the power to make it better.
So where do we start our attack? Not with a bigger, faster processor. Nope. We start with a smarter algorithm. This is our first and honestly our most powerful weapon against inefficiency. Because fixing the actual logic, that's where you're going to get the biggest bang for your buck, the most massive performance gains, often with way less effort than you think. And this right here, this just lays it all out perfectly. Over on the left, you've got your classic brute force approach. It just hammers away at the problem, recalculating the same thing over and over and over again. It's simple, yeah, but it's predictably slow. But then look at the right. That's caching. It does the hard work one time, saves the answer, and from then on, it's basically instant. The difference we're talking about here isn't just a little bit faster, it's absolutely transformative.
Okay, so theory is great, but how do we actually do this? To put this caching strategy into practice, we're going to build a specific tool, a custom, high-performance generic cache class. Let's call it the TDHP cache.
I mean, it really boils down to this, doesn't it? Don't recalculate what you already know. It's so simple, but it's incredibly powerful. Why would you waste precious CPU cycles solving a problem you've already figured out? It's the absolute definition of working smarter, not harder.
So this TDHP cache, it's built for exactly this purpose. The best way to think about it is like your application's short-term memory, but specifically for those really expensive, time-consuming operations. And because it's a generic class, you get to tell it what kind of key and value you're storing. So maybe the key is a string input and the value is a complex result object. You calculate it once, pop it in the cache, and the next time you ask for it, bam, it's there instantly.
And here's the flow, broken down into 3 super simple steps. Step 1, a request for data comes in. Step 2, before we do anything else, we check the cache. Hey, have we seen this before? Step 3 is where the magic happens. If the answer's in the cache, we just hand it back. Instantly. Done. If it's not there, okay, we do the hard work and compute it. But, and this is the crucial part, we stick that new result into the cache before we send it back. That way, we're ready for next time.
Okay, so caching is amazing, a real game changer. But it's not a magic wand that fixes everything. Sometimes the problem isn't that you're recalculating things. Sometimes the problem is the way you're storing and handling your data to begin with. So what do you do when the bottleneck is your actual data structures? When your lists and dictionaries are the things slowing you down?
Well, that brings us right to solution number 2. It's time to level up our toolset. For really complex data handling, we can bring in the big guns, a powerful, modern library called Spring for Delphi. Seriously, think of this as a massive power-up for how your application manages data.
And just look at this comparison table. It really says it all. You've got your standard VCL collections, like the old T-list. You know the drill. You're constantly casting objects, which is not only slow, but just begging for runtime errors. But then you look at Spring. You get strong, type-safe, generic collections. You know, iList T. Bugs get caught at compile time, not by your users. Plus, the performance is just on another level. And the readability? Instead of a clunky for loop to find something, you can write a single, clean, fluent line of code. It is a night and day difference.
The bottom line is, why reinvent the wheel? Why spend your time writing and debugging complex sorting or filtering logic when you can just leverage a battle-tested library like Spring for Delphi? You get all of this power right out of the box. We're talking about modern interfaces that developers expect, like iList, iDictionary, and iEnumerable. It saves you time, it cuts down on bugs, and it gives you a huge performance boost. It's a no-brainer.
Wow, okay, so we have covered a lot of ground, right? We started by identifying our enemy, slow code, and then we looked at two really powerful ways to fight back. So let's wrap this up and boil it all down to the key takeaways that'll help you go from slow code to pro code.
All right, here are the 4 big principles to tattoo on your brain. First, and this is the most important one, fix the algorithm before you even think about blaming the hardware. Second, use a cache. Stop doing the same work over and over again. Third, don't be afraid to leverage modern libraries like Spring for Delphi for your heavy data lifting. And finally, never ever underestimate the massive performance gains you can get from just a few small, clever changes in your logic.
And if you're wondering, is it really worth the effort? Just look at this number. We are not talking about a tiny 10 or 20% bump here. By doing what we've talked about, by moving from a dumb, brute force algorithm to an optimized cache solution, you can see performance gains of more than 10 times. That is the kind of change your users don't just notice, they will thank you for it.
So, I want to leave you with a question. Think about the app you're working on right now. You know the one. Think about that one screen, that one report, that one feature that just drives you crazy every time you use it. Now that you're armed with these ideas about caching and better data structures, what's the very first bottleneck you're going to go out and eliminate?